Section 1. Introduction to Plane Trigonometry. Plane trigonometry is a branch of mathematics. It deals with relationships between sides and angles of triangles. These triangles are on a flat surface. This field has ancient roots. It began with the study of astronomy and land surveying. Today, it's a crucial part of many scientific fields. The word trigonometry comes from Greek. Trigonon means triangle. Metron means measure. So, trigonometry literally means triangle measurement. It's about more than just triangles, though. It's about relationships between angles and distances. These relationships are key in many areas of math and science. Plane trigonometry focuses on two-dimensional space. This is different from spherical trigonometry. Spherical trigonometry deals with triangles on curved surfaces. Plane trigonometry is simpler. It's the foundation for more advanced math. It's used in calculus, physics, and engineering. Understanding plane trigonometry is crucial. It helps solve real-world problems. These include finding heights of buildings or distances between points. It's used in navigation, architecture, and even music theory. Trigonometry is a powerful tool. It connects geometry and algebra. This makes it a key part of mathematics education. Section 2. The fundamental trigonometric functions. The core of trigonometry is its functions. The main ones are sine, cosine, and tangent. These are often shortened to sin, cos, and tan. Each function relates to ratios in a right triangle. A right triangle has one 90-degree angle. The other two angles always add up to 90 degrees. In a right triangle, we name the sides based on an angle. The hypotenuse is always the longest side. It's opposite the right angle. The adjacent side is next to the angle we're focusing on. The opposite side is across from this angle. These terms are key for understanding trig functions. Sin or sin is the ratio of the opposite side to the hypotenuse. Cosine or cos is the ratio of the adjacent side to the hypotenuse. Tangent or tan is the ratio of the opposite side to the adjacent side. These ratios are always the same for a given angle. This is true no matter the size of the triangle. We can use these functions to find unknown sides or angles. For example, if we know an angle in the hypotenuse, we can find the opposite side. We'd use the sine function for this. These functions are the building blocks of trigonometry. They're used in more complex problems and in other areas of math. Section 3. Exploring right triangles. Right triangles are the foundation of trigonometry. They have one 90-degree angle. This makes them special. We can use the Pythagorean theorem with them. This theorem states that a squared plus b squared equals c squared, where c is the hypotenuse. This helps us find unknown sides. Let's look at an example. Suppose we have a right triangle. Its base is 3 units and its height is 4 units. We can find the hypotenuse. We use the Pythagorean theorem. 3 squared plus 4 squared equals c squared. This gives us 9 plus 16 equals c squared. So, c squared equals 25. Taking the square root, we get c equals 5. Now let's use trig functions. In this triangle, let's focus on the angle at the base. The opposite side is 4. The adjacent side is 3. The hypotenuse is 5. We can find all trig ratios for this angle. Sin equals 4/5, cos equals 3/5, and tan equals 4/3. These ratios are useful. They help us solve problems involving right triangles. For instance, we can find angles if we know sides. Or we can find sides if we know angles. This is the power of trigonometry. It lets us solve complex problems with simple ratios. Section 4. Common trigonometric identities. Trigonometric identities are equations. They are always true for all values. These identities help simplify complex expressions. They're tools for solving trigonometric problems. Learning them is key to mastering trigonometry. One basic identity is sin squared theta plus cos squared theta equals 1. This is called the Pythagorean identity. It's true for any angle theta. Another useful identity is tan theta equals sin theta divided by cos theta. This relates tangent to sine and cosine. These identities come from the definitions of trig functions. There are also angle sum and difference identities. For example, sin of a plus b equals sin, a cos b plus cos a sin b. This lets us find the sin of a sum of angles. Similarly, cos of a minus b equals cos a cos b plus sin a sin b. These are useful in more advanced problems. Double angle formulas are another type of identity. For instance, sin 2 theta equals 2 sin theta cos theta. This relates the sine of a double angle to the sine and cosine of the original angle. These identities are powerful. They let us simplify expressions and solve equations that would otherwise be difficult. Section 5. Solving triangles, methods, and applications. Solving triangles means finding unknown sides or angles. We use different methods depending on what we know. If we have a right triangle, we can use trig functions directly. For non-right triangles, we need other techniques. The law of sines is one such technique. It states that a over sine A equals B over sine B equals C over sine C. Here, A, B, and C are sides. A, B, and C are opposite angles. This law works for any triangle. It's useful when we know some sides and angles, but not all. Another important tool is the law of cosinus. It states that C squared equals a squared plus B squared minus 2AB cosine C. This is like an extended Pythagorean theorem. It works for any triangle, not just right triangles. We use it when we know 3 sides or 2 sides and the included angle. These laws have many real-world applications. Surveyors use them to measure land. Engineers use them in construction. Astronomers use them to calculate distances in space. Solving triangles is a fundamental skill. It connects trigonometry to practical problems in many fields. Section 6. Trigonometric equations, a step-by-step approach. Trigonometric equations involve trig functions. Solving them is like solving algebraic equations, but they have some special features. We often need to use identities or special techniques. The goal is to isolate the variable we're solving for. One common type is a simple equation like sine of x equals 1/2. To solve this, we use the inverse function. In this case, x equals arcsine of 1/2. But remember, this isn't the only solution. Sine repeats every 360 degrees, so we need to consider all possible angles. More complex equations might involve multiple functions. For example, sine of x plus cosine of x equals 1. We can't solve this directly. We might use the substitution method. Let u equal sine of x and v equal cosine of x. Then we have u plus v equals 1 and u squared plus v squared equals 1 from the Pythagorean identity. Solving trig equations often requires creativity. We might need to factor, use identities, or make substitutions. The key is to simplify the equation. Then we can solve it like an algebraic equation. Finally, we check our solutions to make sure they work in the original equation. Section 7. The power of trigonometry in real life. Trigonometry isn't just for math class. It's used in many real-world situations. Engineers use it to design structures. Architects use it to plan buildings. Even artists use it to create perspective in paintings. Trig is a powerful tool in many fields. In navigation, trig is crucial. Pilots use it to calculate flight paths. Sailors use it to determine their position at sea. GPS systems rely on trigonometric calculations. These help pinpoint locations accurately. Trig helps us understand and use space effectively. Physics relies heavily on trigonometry. It's used to analyze forces and motion. For example, when studying pendulums or waves, trig functions are essential. In optics, trig helps explain how light behaves. It's key to understanding refraction and reflection. Even in everyday life, we use trig concepts. When we estimate distances or heights, we're using trig principles. When we adjust the angle of a ladder against a wall, we're applying trigonometry. Understanding these concepts can help us solve practical problems. It gives us a deeper appreciation of the world around us. Section 8. Key concepts revisited. Let's review the main points of plane trigonometry. First, we have the basic trig functions, sine, cosine, and tangent. These relate sides and angles in right triangles. They're the foundation of all trig concepts. Understanding these is crucial for success in trigonometry. Next, we explored trigonometric identities. These are equations that are always true. They help us simplify complex expressions. We can use them to solve difficult problems. Memorizing key identities is important, but understanding why they work is even more valuable. We also learned about solving triangles. This involves finding unknown sides or angles. We use the law of sines and the law of cosines for this. These laws work for all triangles, not just right triangles. They have many practical applications in various fields. Finally, we looked at trigonometric equations. Solving these requires special techniques. We often use identities or substitutions. It's important to consider all possible solutions. Trig equations appear in many real-world problems. Being able to solve them is a valuable skill. Section 9. Resources for further study. To deepen your understanding of trigonometry, many resources are available. Textbooks are a great starting point. Trigonometry by Mark Dugopolsky is comprehensive. It explains concepts clearly and provides many practice problems. Sham's Outline of Trigonometry is another excellent resource. It focuses on problem-solving techniques. Online resources can supplement textbook learning. Khan Academy offers free video lessons. They cover all levels of trigonometry. The website mathisfun.com has clear explanations and interactive tools. These can help visualize trig concepts. For more advanced study, MIT OpenCourseWare offers college-level materials. Practice is key in mastering trigonometry. Websites like iEqualMath and Brilliant offer interactive problems. These adapt to your skill level. They provide immediate feedback. This helps reinforce concepts and build confidence. Regular practice is essential for success in trigonometry. For those who prefer a more structured approach, consider online courses. Coursera and edX offer trigonometry courses from top universities. These often include video lectures, quizzes, and peer discussions. They can provide a more comprehensive learning experience. Remember, the key to mastering trigonometry is consistent practice and application.